And we're live. Hi, everyone. Welcome to another on.NET Live. My name is Cecil Phillip, and I'm so glad to be back with you all today. I have my friend here, David Glick, and David's going to be talking to us about some really cool things that we could do with the Razer View engine. Now, with that being said, I feel like it's been a really long time since we've had a stream. It hasn't been that long. It's actually been only like 2 weeks, but it feels like a long time to me. Also been on vacation and it's summer, and the kids are doing stuff, and people going on trips and all those types of things. So I hope all of you have been well. Hope you've been enjoying your time off and spending time with your families and staying safe and all that type of stuff. But with that being said, David, why don't you really quickly tell us a little bit about yourself and who you are and what you do, and all the cool stuff that you're working on.
Yep. Okay. Hey, everyone. I'm happy to be back, Cecil. This is a fun show. Always happy to visit. I am Dave Glick. I work by day building line of business applications, but that's boring. So by night, I work on open source and whatever I think is cool. So I've done quite a bit of work on MS Build, on Razer Engine, which is what we're talking about tonight. And I kind of try and bring all of that together in my biggest project, which is Static, a static site generator for .NET. But that's not the subject today. We're going to talk about Razer today, which is really cool and fun.
I feel like we should have some theme music for you when you say that. Like developer by day, right? Developer by day, open sourcer by night. Yeah. We should get like a little cape that comes down and everything. And
that's right. Yeah.
Overlaid over your video or something. So another thing we like to do on the show is also, I like to always recognize all of our viewers. I know we always have viewers from all over the world that watch us. Really appreciate you wherever you are, whatever time zone that you are, for spending the next hour or so with us today, talking about all the cool things in .NET. Me personally, I know I'm in Florida. Dave, I don't know if you want to tell folks where you are, but you're in the United States, right?
Yeah, I'm just outside DC, East Coast.
There we go. And I know we have some folks in the stream calling in from or watching from, I see some folks from Brazil, from India. I see folks from all over the place. So as always appreciate y'all spending your time with us on Thursdays, as we talk about all the cool things and fun things about .NET. Now, before we actually dive into and start talking about, all the fun stuff Dave's going to talk to us about, I actually want to share some links because, this is what we do, right? We share links and stuff sometimes. And so the first couple of links that I want to share with y'all, some of you may or may not have known this, but .NET 6 Preview 7 was released just, what day is it today? Like 2 days ago. So if you've been following up with the preview releases, definitely go ahead and check out Rich's blog post on the .NET blog. It highlights all the great things that they've done, from performance to, a lot of the cool things they released with Maui. There's definitely been a lot of work in this particular release when it comes to the project templates. Some of them have been, updated and simplified and tweaked a little bit to, more align with some of the things that we want to do today. Also talks about other things like hot reloading and, live preview for web forms and all that kinds of stuff. So if you're interested in learning about that, definitely go and check out the blog post. And also please go ahead and download .NET 6 Preview 7 and let us know what you think about it. Now, the next link I want to share with everyone is this one. So C# language highlights is something that we've been doing for a couple of months now. Like every week, we try to release at least one video that highlights a really cool feature about the C# language itself, and sometimes even like cool libraries in the BCL, the base class library that you may or may not know about. And in this particular video, this also just released fairly recently, we have Leslie and Brandon, and they're here talking about the immutable collections. That are really cool feature that are a really cool set of libraries that have been in .NET for a while. Some of you may or may not know about it. So definitely go ahead and watch this video and check them out. And again, as always, our highlight videos are always really short. So these are, this is less than 5 minutes, right? So probably by the time you walk downstairs and get a drink from the fridge and walk back upstairs, you could have watched this video. You're going to learn something new about immutable collections. And now the last video, or the last link that I want to share with you folks, our friends at JetBrains actually do a lot of cool stuff when it comes to .NET, just in general, from tooling to content and videos and things of that nature. So I definitely want to give a quick shout out to my friend Rachel Appel, and she does this .NET annotated monthly blog post where she collects lots of different types of .NET news and articles and blog posts that a lot of you folks in the community are writing. And she kind of curates them together and puts together this really interesting, like kind of like the month in .NET type post. So there's a lot of awesome stuff in here, as you can imagine. Tons of stuff about .NET Core, ASP.NET Core, C# 10, again, and tons of other stuff in there as well. So definitely recommend you head over to the .NET Tools blog for the JetBrains folks and check that out, and then see all the other cool stuff that they're doing over there too. Okay, now that being said, this is the part where I say, this is no longer the Cecil show. I'm going to take my screen off. And now this is the Dave show. So Dave, let's talk a little bit about Razer, right? Or before we even talk about Razer, let's talk about templating, right? Why is templating and templating languages so important for developers today?
Yeah, so templating languages are kind of their own special little thing that we use a lot when we're trying to build out content. You can, if you have a web page you need to render, or you want to write an email, or some other content-oriented output, you could write a whole bunch of string append. You could use a string builder, but yeah, that gets really hard because you've got all this extra code that's sort of managing the raw content that you're trying to output, especially if the raw content is the bulk of what it is that you're working on. So a templating language lets you write syntax that jumps between the content that you want to output in its raw form and the code instructions that are going to help create that content in the way you want. A great example is things like loops. You may, let's just go text right now. Say you're writing a plain text file, but you want to do a loop 10 times and write the same string out 10 times in a row. That's not straightforward to do necessarily. If you're trying to write all the surrounding code, write the text, whatever it is. So templating language, you can put your looping code right inside the template. Basically, you write the stuff before you loop. You split out into the code to put your for statement or your for each. Then you put more content, and then you go back to code to kind of close that, and then you go back to so you're jumping back and forth between the two. So templates are great for this kind of content-heavy output activity. Now, Razer is not the only template language that we as .NET developers have access to. In fact, other ecosystems have all sort of created their own de facto templating languages. One that I particularly like is called Liquid, which came out of Shopify and is now fairly popular in Ruby. In .NET, we have an engine that can render Liquid templates, created by Alexandra Mutel, who you may know from MarkDig, the Markdown renderer. It turns out he's a big fan of templating engines, so we went and wrote one for Liquid as well. In JavaScript world, they've got Handlebars, Mustache. .NET has open source engines for those as well. So there is a lot of possibility out there as far as templating engines go. But Razer is kind of emerged as the de facto .NET one, particularly because it plays well with .NET code, which we'll look at in just a second.
And when we think about templating too, I think for most of us as .NET developers, every time we say templating, we always think web related things, right? We always think, generating, I don't want to reuse the word template, but generating like those layout pages, right? Where they have the child pages and the parent pages, right? And so we want to have like a consistency across our different UIs.
Yeah, that's right. And that's actually a great point because it's not just web. That's kind of where templates have come to shine. But people use them for all kinds of really clever, innovative stuff like email, reporting. Mattias in chat mentions T4, which is a .NET-oriented templating language to generate code. Code that generates code. As a template language. So they can be used for all kinds of interesting things.
For sure, for sure. And kind of like you said, like even though Razer's kind of like built in the box when you think about ASP.NET type things, like there's tons of other ones in a community that folks could try and try out and play around with, like Liquid, like you said, or there's handlebars I know a lot of JavaScript folks use and things of that nature.
Yeah. So I put up a little comparison here of Liquid versus Razer, and the reason I'm putting this up, and I want to discuss it very briefly, is to kind of point out that the template language at a language level is really about how you jump between content and code or instructions. So both of these templates produce the same output. And you can see the main difference is not the content itself. It's not the HTML. That's the same, right? Because that's our content here. But it's the way that we're instructing whatever engine is running this template to jump between instructions and the content. It's not even so much the syntax, because Liquid has this kind of neat built-in for in kind of syntax that kind of flows nicely in HTML, whereas in Razer we use plain old C# code for our instructions. Right. But the point here is that each one has a convention for how it jumps between the two. And that there is this jumping that in Razer, we kind of indicate that using an @ symbol. In Liquid, it's done with this double brace thing. The role of a templating engine, and now we're kind of getting into Razer as a templating engine. The role of the templating engine is basically to take the raw content and intersperse it with the instructions you've given it in a way that it can be re-executed to produce the final output.
Oh, yeah. And just really quickly, it looks like we just got rated on Twitch. So it looks like Cassie Doo has rated us with 173 folks. So that's definitely
that's
awesome.
fun. Hi everyone.
Shout out to all the new folks that have joined us. Definitely appreciate you, Cassie, bringing your folks over here to hang out with us. So for those of you that have joined us and have never probably been to this channel before, this is the On.NET show, and we're talking to Dave Glick today, and Dave's going to be talking to us about templating, right, and using templating outside of like the web context to do other cool things. So that's what we're kind of just doing right now. We're talking about templating and different uses and different types of templating languages, and then we're going to kind of dive into using the Razer templating language outside of a web context in a second. So if that sounds cool, I hope you all stick around and hang out, and hope you guys enjoy the show.
Yeah. So you're just in time for the good stuff, because I have.
Does that mean demos?
A chart? No, it's a diagram. Everyone loves diagrams. I almost put in a PowerPoint because everyone loves PowerPoint too. But no, we just have a nice little pretty chart here. So the question is, what happens? What does the Razer engine do when we feed it something like this? What happens? How does this turn into something that we can run,
right? That
we can produce output with? That's kind of the what's going on behind the scenes. And so it essentially breaks down. And this isn't super technical or anything. Don't like run over to the ASPNET team and tell them, well, Dave said it works like this. This is just very high level, but there's basically four pieces that happen here. When we take a Razer template, usually that's a CS HTML file that looks like what we just looked at. But in some of these libraries, that can just be a raw string. It can come from a database. You can pull it from an embedded resource. However you get that string content that includes your Razer syntax, you feed that into the first phase, which is sort of a straight up parser. Now the parser does a lot of things, but the main job of the Razer parser is to identify those locations where you're breaking out of the content into code and going back into content. Now the rules of the Razer language can get kind of complicated because it's not always clear when you need a brace after the @ sign, and then you've opened the code scope, and when does that code scope close? And sometimes if you've done enough Razer, you end up in situations where you need to kind of break out of code, but there's no good way to do it. So you end up with these kind of special text elements that don't translate to the content, but they look like HTML and they're just a special instruction to Razer. The parser is what handles all of that. It has all of the rules for the Razer language and goes through your entire Razer template and outputs this syntax tree that says, here is a chunk of text that I want to output. Now here's some instructions. And then inside those instructions, there's some other chunks of text that we want to output, and so on. So it ends up producing.
Right. Now, here's a question for you, real quick, Dave.
Yeah.
Yeah, here's a question for you, real quick, because I know for a lot of folks, every time we talk about templating and compiling, that folks are always like, "Why do I have to compile the template?" Right? Because, like you said, it's a bunch of text with some code in it. But if it's just a for loop, why can't my for loop just spit around and like just do copy paste, right? But I'm guessing there's more that's happening there other than just like a copy paste code, right? Like, which is why the compilation step is important.
Yeah, that's a very good point. And I think the key here is all about performance and caching when you get right down to it. We could do all 4 of these things every time in kind of one big fell swoop. And you could just write the code that does all this and goes from template to rendered output.
To markup,
in kind of one big thing. But it wouldn't be very performant because you'd have to do it every single time. And it turns out that this parsing phase, and particularly the code generation and compilation phases, take a little bit of time. It's not super a lot of time, but it's enough that you'd notice if you were doing it for 1,000 requests a second or something. Right. So the goal of this process, as we kind of move through the phases here, is to end up with a result that is as fast to render with different inputs as possible, so that we can basically do all the work we can beforehand and get a result that requires only a minimal amount of effort to generate our final output when conditions change.
Gotcha. And that makes sense. And just looking at the chat really quickly, we have a question from our friend Romain from YouTube. And he's asking, does the Razer engine transform our .NET Razer code into JavaScript/HTML?
Good question. So no, the Razer engine will not on its own translate anything into other code. What it will do, though, is help produce JavaScript code in the output if you've written that as part of your input. So if we go back to what a Razer template looks like, if you had written a script element inside of your template here and put JavaScript code in that, that'll end up in your final output. And what I've seen people do, and do myself, is actually intermix the JavaScript code with your Razer template. So that's a little bit of a, if you've never done it before, because it's kind of the intro. All the examples for Razer show you as using Razer interspersed with HTML. But as a templating language, it doesn't really care what the stuff around your Razer syntax is. It'll output anything. It doesn't even have to be HTML or web-based. It can just be plain text. Sure. So if you had some JavaScript in there, you could do something like, at product description substring, you could put this bit of Razer syntax inside your JavaScript and have that produce a string within your JavaScript code, just the same way you have it produce something inside your HTML code. So in that way, you can get really, really crazy with like JavaScript code that is partially generated on the server. And I actually use that to eliminate things like magic strings and unify models between my server and my client. If I've got client code that needs to use a model that exists on my server, a lot of times I'll write some Razer syntax that helps make sure that the JavaScript code is being generated in a way that matches up with my server-side model, rather than write it all out longhand and risk mixing those two things up.
Right. And then here's another point I kind of want to make, because I know we might have some folks here that are not 100%, into what Razer actually is. So when we say templating with Razer, what Razer actually does is it generates code and not necessarily just raw HTML. And what happens is that that code exists on the server side, right? So ASP.NET is a server-side language.
Well, sometimes exists on the server, unless you're doing Blazor.
Unless you're doing Blazor. Traditionally speaking, it exists on the server. And so when you hit the server, what happens is that compiled template is now run and generate. Essentially, it's a bunch of functions, right? And those functions are run. Your data is input, your tables, your whatever information you have is put into that template, generates the HTML and sends it over. But if you're thinking that, oh, hey, I'm going to run this Razer thing within the context of ASP.NET and then look into the folder and see like .html files in the folder at rest, then no, it doesn't do that, right?
No, unless you're
Because
using
again,
a static site generator.
unless you're using a static site generator, which I'm pretty sure we're going to get to in a little bit later on. And I saw some folks in the chat talking about
I
it.
gotta put a plug in when we're done.
We got to do it. We got to do it.
Yeah. So I do see a question from Phillip, or a statement that using Razer as a templating engine in your own apps is hard to do, and there's a few projects, but they're hacky. Stay with us. In about 5-ish minutes, we will address that, hopefully, and kind of blow your mind a little. But in the meantime, we'll finish out this little chart here because, Cecil, what you just said is exactly where we're going. And that is that once we get the syntax tree, the Razer engine does a code generation step, which essentially produces C# code. Now, it's not really C# code. It's more like another syntax tree that Roslyn, which is the C# compiler, can understand. But you can think of it like a chunk of C# code. And it literally is a series of writes to a stream that are your raw content interspersed with instructions that you put in your Razer files. So if we look at what a Razer template looks like, what you'd end up getting inside of that generated C# code that gets compiled for your Razer template is literally a stream write UL ID equals products, and then literally the code for each var product and model products, and then another set of stream writes, and so on. And the Razer code generator is responsible for outputting the C# code that intersperses those things. And if you've ever seen like complicated Razer templates, they can get pretty, it can get pretty hairy, right? You can get 5-6 levels of nesting deep between content and code instructions. So the code generator is what's responsible for kind of taking this syntax tree from the parser and turning all of that into a class that has a single render async call. And the method is actually called render async. You end up with a .NET class with a render async method once you go through this compilation phase. And it emits an assembly. Depending on the style of caching being used, the assembly that contains that class that represents your Razer template sometimes is output to disk as a temporary file. Sometimes it's stored in memory as a dynamic assembly. But there is always this assembly that can be called.
And I guess when you think about it, also for folks that may be familiar with things like React, right, and JSX, I'm guessing Razer is almost like, I'm trying to be very careful with the words I use. I'm guessing Razer is almost like our server-side render JSX from the perspective of, and again, I'm saying that because we've had it before.
Yeah, it would be somewhat equivalent to server-side rendering of like a JSX template.
Right, and I'm saying that from the perspective of when you write JSX, essentially what happens after you run it through Webpack or whatever build thing that you're using, it's going to take that markup and it's going to generate JavaScript code. You know what I mean? And then that JavaScript code becomes dynamic and you do stuff with it, right? Just in the same way, Razer, when you run it through our compilation process or our build process, it's going to generate C# code, right? And then, we pass it along to your data, right? And it generates stuff with it, right? So that's kind of how it's somewhat similar.
Yeah. So I see another question about whether you can have Angular React in Razer. Absolutely. I mean, just like with JavaScript, how I mentioned earlier, the trick is to think of your Razer template really as just a bunch of stream writes or as a string builder that you're appending to, if that's easier to kind of conceptualize. But anything you put in your Razer template will end up in your rendered output. It can be JavaScript, it can be any JavaScript library. It doesn't have to even be HTML. It can be any kind of content. Razer treats it all equivalently. Now, Razer does have some special sauce that can recognize like HTML tags and do stuff with that, but it doesn't have to be. You could output really any kind of content if you wanted to.
Right. So how about so I know we've been talking for a little bit. Is it time to look at demos yet?
Yeah,
Like, I
let's
really
look
wanna
at some
see
code
demos.
because we've got a bunch of people in chat talking about trying to run Razer on their own, and let's show them how to do that. Oh, but the last part, real quick before we do that, just one last part. The dots here, there's one last phase, which is once you've got this assembly, and that's kind of the job of the engine. How does it get run? In ASP.NET, that's kind of these dots represent what ASP.NET takes over. So the Razer engine produces this assembly. ASP.NET will then handle a request coming from a browser, glue it together with the assembly, run that render async call, and produce your HTML that then gets delivered back to the client. If you use a other engine to run Razer, what you're essentially doing is taking out this bit with the dotted lines and the execution bit and replacing it with your own application and your own code that can do whatever you want it to do.
Right.
So that's kind of where the code we're about to look at is playing in this kind of lower left corner of the diagram here.
Let's do it, man. Show me the code.
Yeah, so let's see. So we've got, I've got 3 quick samples. They all have the same Razer template and produce the same output, so you can compare and contrast. The first one we're going to look at is from a project called RazerLight. Now, there were a number of attempts over the years to kind of libraryize the Razer engine. One called Razer Engine got a lot of popularity in the .NET Framework days. Unfortunately, it hasn't quite caught up with .NET Core and ASP.NET Core. So there's a few sort of spiritual successors. RazerLight is one of those. So the idea here is RazerLight uses an engine concept where you create a Razer engine, and that is a object that you create and you keep an instance of. And then you feed that engine your templates, and it produces outputs for you. So the template we're going to render is a real simple one, a single div tag. But it's got 2 things I want to point out. One is that we're using a property from the model. So the concept of a model is kind of inherent in Razer as a convention. You can pass a model to your template, and the template can then access any properties of this model using this model syntax here. And then we're also going to pull out some ambient static information just to kind of show something that is not the model. So one thing I want to mention when we're talking about RazerLight, there's Razer and then there's Razer. The Razer engine, as it exists today, is somewhat distinct from the ASP.NET version of Razer. So the Razer engine is modular, and that's been important for the ASP.NET team as they build out other uses for Razer, like Blazor. They both use the Razer engine, but they put different stuff on top of it, so they have slightly different functionality. Razer Pages is another good example of an idea and feature that uses the Razer engine, but glues some other stuff on top of it. So I'm saying that because RazerLight uses the Razer engine, but does not use any of the ASP.NET bits, at least not extensively. Okay. So it has support functionally for things that you might be used to, like layouts, partials, that kind of thing, the model. But those are not necessarily a given. All those things are kind of glued on top of the Razer engine as extensions. Right. So the syntax in RazerLight to do something like a partial is going to be slightly different than it is in ASP.NET. I think they call it an include in RazerLight. But at the end of the day, it's still Razer, the language, and the same Razer engine being wrapped. It's just not the higher level ASP.NET Razer extensions, if we want to call them that.
Yeah. There's a question in here in the chat coming in from Twitch. Person's asking, are there any sites you're allowed to mention that use Razer templating? I would tell you, I don't know if we track that. I mean, we could tell you sites that use ASP.NET, and anybody that's using ASP.NET Core for web front ends more than likely are using Razer. like 90%, 98.52341%.
Yeah,
of
you can
them
actually
are
hook
probably
in
using it.
other templating engines into ASP.NET if you want to, but like no one ever does.
Yeah, you can, but I mean, so once you hear folks are using ASP.NET Core or even ASP.NET MVC as well for their front ends, they're probably using Razer. I don't have any numbers, but I could pretty much guarantee that for you.
Yeah, so you can see here with RazerLight, we took our template, which is encoded in a string. Again, that could be a file, it could be an embedded resource, however you want to store that and get it is fine. But RazerLight lets us get from a string-based Razer template to rendered output in, I guess, essentially 2 lines. If you take out my wrapping here, we build the RazerLight engine. This is a requirement, but it's really the only requirement. It basically tells it that I'm setting up a file system here. So if I have an include or a layout, it's going to look within my project for those files. That's what this part is doing.
So here's a quick question for you. And like I'm looking at your code and I'm also looking up the samples on the RazerLight GitHub page. On your line 18, there's that GUID thing.
Yeah.
And it's the same GUID that's in the sample.
Yeah,
Like the sample
copy and paste.
Oh, okay. But what's the significance of that GUID? Like, do I need that, or like what is that for?
You need something here. So GUIDs are really, really expensive, and there's a limited number of them. So I didn't want to use up one, and so I just copied and pasted the one that they were using.
Okay.
But so what this really is, joking aside, is it's a cache key. The RazerLight engine has built-in caching. And this string here, it could be anything, right? I could just, I could do that and we'll run it.
It can be whatever.
Yeah, it can be whatever. I've seen people use timestamps sometimes is helpful for this. You could hash the content. That's another way of doing a cache key. But the idea is this key is what tells the engine for a given template whether it can reuse the compilation it previously created for that template, or whether it has to create a new compilation and take a little longer. So that's just to kind of help with that process.
Got it.
The other thing here on line 20 to quickly notice is I'm creating a new anonymous object, and this third argument to my compile render string async call is going to be my model. So this is creating an anonymous object for my model and setting the name property to my name, which comes out here and ends up in my rendered output there.
Okay. So then another question then really quickly about line 18. Does that mean that every different type of template I should use a different GUID because it's cached?
Yes. Yeah. If you try and use the same GUID or same cache key for a different template, bad things will probably happen.
Got it. Okay.
I think under the hood, it's probably doing some sort of hashing of the template content as well and combining that with the cache key, but you don't really want to risk it. So it's better to come up with some sort of unique, and the trick is you want, and this is going to be true for any implementation. The next two we look at don't really do their own caching like this, or the caching is internal, so you don't have to worry about it. But if you wrap your own caching layer around it, you're going to want to do something similar. You just need some sort of something that you can change when the template changes, so the engine knows it needs to rebuild it.
Got it. Okay. So, but the sample looks pretty straightforward, right?
Yeah. So this is what I say. So hopefully the folks who are saying it's really hard to do this, there's a lot of new projects, RazerLight being one of them, that are like way easier to use than the old .NET framework days. Part of that's due to improvements in Razer engine to make it more general purpose, which the team had to do to support Razer pages and Blazor anyway. And part of it is, .NET Core makes for a nice development experience and makes for some of these newer style APIs to be developed a little easier. So folks are doing that.
So do I have any gotchas when I'm using this like Razer?
Yeah, so I mean, RazerLight, your gotchas are going to be that things you're used to doing in ASP.NET Razer, if you're used to ASP.NET, are not necessarily going to work the same way. For example, tag helpers. There's no And someone can correct me, but my understanding is there's no tag helpers in RazerLight.
Okay.
So that's a whole class of things that may not be available for you if you're used to using those.
Okay, but like outside of like those ASP.NET specific things, I'm guessing I have the same support for CS HTML files. I have the same support for those language features.
Yeah.
Right. Like everything else should be fine outside of like those ASP.NET isms.
Yeah, exactly. Yeah, and the trick is just knowing for whichever engine you use, which ASP.NET isms it either doesn't implement, it implements in the same way, but using its own custom implementation. So, it could implement something like tag helpers using the same syntax, but with entirely separate code and just copy that implementation. And some engines do that. So yeah, it's just reading the docs and figuring out what you have access to for that particular engine.
Gotcha. Okay, cool. Yeah, again, this one looks pretty straightforward. And then it looks like it renders to a string, right? So you have compile,
yeah,
render,
so I'm just
string,
rendering out to a string here. There's other overloads. You can render it out to a stream. I think there's one that may put it in the file if you want.
Awesome.
But just to kind of show what's going on, we render it out to a string, and then I just write the string to disk, or sorry, to the console, and we end up with that. So the next one I want to look at is called Gazerater.
Gazerater.
Yeah, and I'm going to look at this one because I like the syntax. It's got a nice fluent API, but also because under the hood, it's doing something substantially different from RazerLight. RazerLight uses the general purpose Razer engine, but then implements all of the wrapping stuff itself and all the calls and everything itself. Gazerater takes a slightly different approach and actually uses all of the ASP.NET bits and then calls into that. So Gazerater is kind of like the Razer engine, and then around it, you've got ASP.NET, and then around that, you've got Gazerater that makes calling that easier in this Fluent API. So it's a slightly different approach. It's different under the hood, and can produce different outputs depending on the syntax you're using. But the big difference is that because it's literally ASP.NET, you're getting all of that special sauce and extensions kind of mixed in there. So layouts are going to work the way you're used to in a web project. Partials are going to work the way you're used to, stuff like that. All that syntax is going to be the same.
Yeah, and then, like you said, I definitely like this Fluent style syntax that it's using. I guess the only question I'd wonder, because at this point now we've looked at two different options, right? Gazerator and then RazerLight, would be, I know within the perspective of .NET and probably just programming in general, like string manipulation is performance intensive in general, right? So I'm kind of wondering, like, what would be the difference in performance between these two different libraries? I don't know if you've run any benchmarks or if there's anything.
No, I haven't. I mean, my gut says that RazerLight would probably be more performant just because it's doing less.
Okay.
And ASP.NET has a lot of stuff designed for web environments. And in service of all of that infrastructure, that's going to take some cycles to run through. Even if we're not making use of it, it's still there.
Yeah.
So Gazerater is going to wrap all that and abstract it away from you and hide it, but it's still doing all that extra work, even if we're not making use of it. So my gut feeling is that a more direct implementation like RazerLight that doesn't have all of that extra stuff is probably going to be more performant. But optimization is funny, and there's lots of ways you can go in and try and either write something that's less optimized accidentally and kind of turn that on its head. So you'd really have to benchmark.
That totally makes sense. And let's looking over at Twitch really quickly. We have a question from Guy Creative. It says, I messed around with Blazor a little bit and I really like it. Not really sure what the difference is between Blazor and Razer though. So you want to chime into that?
I can, yeah. Actually, you can do a whole other talk on Blazor, and there's been plenty of those. But the key difference for the purpose of talking about the Razer engine is that Blazor essentially stops here, kind of like you would if you were doing Razer in your own app. Whereas in ASP.NET, when a request comes in, the ASP.NET web server handles it. It finds this assembly, it calls it for you, generates HTML, and then returns that to the client. Blazor essentially takes this assembly, which is compiled on when you compile your Blazor app. We go through these 3 phases to get the assembly. But then what Blazor does that's a little bit different, particularly Blazor, the client-side version of Blazor, because there's also 3 different Blazors, which itself gets confusing. But what the client, like totally non-server version of Blazor will do is it takes this assembly and it actually ships that to the client browser. And then inside the client browser, it runs that assembly inside the client instead of on the server to generate this HTML.
Yeah, the way I kind of look at it as well, kind of like to add on to what Dave is saying, is there's like 3 things in play, right? So if you look at it, there's Blazor, the client side thing that we have, and then there's ASP.NET MVC or Razer pages. And like all 3 of those things use Razer templating.
Yeah.
Right? So most of your Razer code, not all of it, but like the majority of it is going to be the same across those different frameworks, right? Razer pages and MVC are server-side rendered, and Blazor, for the most part, is run in the browser, right?
Yeah, and the trick with Blazor, and I totally recommend going off and watching some other videos because it's really cool the way it does this. But it basically takes this assembly and runs it using something called WebAssembly, which lets us run .NET code, but inside of a web browser. But at the end of the day, it's the same assembly, and it's using the same render async call that we use on the server. It's just doing it somewhere else.
Yeah. And then following up, guys, another question. So apps can run offline then? Yes, you can actually run offline apps with Blazor. There's even support for things like PWAs, progressive web apps, and those types of things that you can get offline support, which is pretty cool. Quick question. I want to hop over to YouTube real quick because we have some folks asking questions there too. And question is what's the advantage of using this style of coding instead of .cs HTML?
Well, so the trick here, it's slightly different use cases. And this may still be, like, I could still put this template in a CS HTML file and read that inside my embedded Razer engine in my own app. CS HTML, that's just a naming convention for the file that says this file contains a Razer template. But I think what you're really asking is, what's the advantage of embedding the Razer engine in my own app as opposed to running it inside of, say, ASP.NET and running it there? And the idea is this opens up new use cases. A good example may be sending out email templates. Say you've got an app that you need to email people when certain things happen. Email can be HTML now. But you want to intermix code with that, right? You want to put in the person's name. It's very much this style of template. Hi, so-and-so. This could literally be an email, right? Using an embedded Razer engine lets you produce HTML or really any kind of content from a Razer template completely outside the context of a web application. And so when you kind of start thinking about where you might use that, all kinds of possibilities open up, right? Like I said, email templates, reporting systems. Yeah. Say you've got like an Azure function and you want to send a PDF report to business users every night, getting data from a database or something. This is a great way to produce that. Find a PDF engine that takes HTML. There are a lot of them that do. And then use a Razer template to produce the HTML that you feed into your PDF engine to produce the PDF that you send. And that can happen all inside like an Azure function without any ASP.NET involved. So there's a lot of interesting use cases that start to open up when you kind of take Razer out of the web context.
Yeah, I know for me in the past, I've used it in a few background workers, right? Like, so things that are not attached to your UI. And let's say, if you folks are doing any type of distributed computer, I've had apps where I've sent messages off to a queue, and I essentially just have a worker app listening for messages to pop into the queue, pull the message out, and generate templates based on the data or the information that's passed along in the queue. So again, if you think about it, sure, you can just use HTML files that exist already in a .NET web application. But if you think about non-web applications as well, again, background apps, desktop apps, content management systems that again are not exactly attached to a web thing, you know what I mean? Generating documents and markdown files and like tons of examples. Those would be some good opportunities for you to use something like Gazerater or RazerLight.
Yeah, so I think we'll skip the last example, but I'll just briefly touch on what I was going to talk about here, because someone brought up in the chat, I can't remember if it was YouTube or Twitch, that they're talking about static generators, and well, isn't that funny? I happen to maintain a .NET static site generator that uses Razer as one of its primary templating syntaxes, and the idea there, for anyone who's not super familiar with the static site generation concept, basically it shifts this part, right? We've talked about shifting this around. That's kind of the whole thing. Like, this is the engine, this is the part we play with, and where that happens. So Blazor removes this execution part and sticks it inside your web browser. A static site generator, so ASP.NET does it at request time. A request comes in, ASP.NET takes this assembly, runs it to produce HTML when a request comes in at request time. A static site generator does it yet in a different way. And the idea is, in a static site generator, you run through all 4 phases at compile time, or at what we call generation time.
Yeah.
So the idea there is the output from a static site generator is pure HTML and JavaScript. So Razer is still great in those scenarios, particularly for things like layouts, because it lets you write code that's evaluated during your site generation process. So I may still want to do something like include, a model and have a name, and maybe that name changes depending on the day and time I was building the site. Maybe I add a new blog post, and so I need some sort of language to go through all of my blog posts and output a list of them. The idea is we can do that all at once if we don't have anything that we need to know about coming in as a request, or if we can offload that to JavaScript instead of having that part in the Razer code. So that's what static site generation does. And static with a Q is a .NET-based static site generator that leverages Razer as an engine to generate static sites.
Yeah, and then Dave, you were actually on the show.
Yeah, there's a previous on .NET. Yeah,
I'm going to look for it right now. But you were on the show a couple months ago, and you talked about static with a Q. And
that was I like to say the Q stands for quality, Cecil.
A Q stands for quality. I just found the link to the video. It was actually August 2020. It's almost a year ago to the date, to be honest with you.
Okay.
So I'm going to go ahead and post the video in the chat for folks that want to check out Dave's previous visit on the stream, where he talked about some of that stuff, in case you want to learn more about static and the project and the history of it and some of the cool things that it could do. Boom. Great. There we go. All right. So so you're saying we're not going to look at the static demo? Are we going to look at the static demo?
We can. So I'll just throw up the code here. It does the same thing. What you'll notice is it's a bit more complicated because it's kind of so if RazerLight and Gazerater go about the idea of turning a simple text template, or it could be in a file, but turning a Razer template and rendering that into a string or somewhere else to get an output in as simple a way possible, you kind of remove their whole goal is to abstract or remove a lot of the complexity from the process. Static, because you're usually using it within the context of the static site generator, a lot of that's hidden too. But if you want to use Razer directly through static, you can do that too, and that's helpful in scenarios where you're trying to intermix pieces of your static site generator built with static with raw Razer engine usage. And so you can see here, the first thing you'll notice is this actually looks a little more like ASP.NET E. right? We're creating a service collection. We're adding a bunch of dependencies to that service collection. I'm creating an engine. I'm adding these pipelines that creates a flow where I read the template. I set some, in static terms, it's called metadata, but that gets translated to the model. I render the Razer using this call here. So doing it this way lets us string together more stuff. If we wanted to make this Razer rendering part of a broader overall process that uses bits and pieces from static, if you're already used to that, you can do it that way too.
Nice. And as an example project, I believe the .NET Foundation website uses static with a Q, right? For some of their parts of the website.
Correct. Yeah. The .NET Foundation website is built using static. Yeah. So if you want to take a look at a moderately complex static site and how that works, go check out the .NET Foundation's repo.
Awesome. Yeah, that definitely sounds great. I'm looking for I'm actually going to the GitHub repo now to look for the .NET Foundation GitHub. I don't know if you have it by hand, but if not, I'll just pull it up really quick and drop it in the chat so folks can head over there and check it. But I believe it's github.com/.NET Foundation /website or something like that.
Yeah.
I'm going to look it up real quick and drop it in there for folks. But while we're looking for that, for folks that are still here with us, I hope you guys have liked what you've seen so far. I mean, if you have any questions at all for Dave, definitely let us know. And we can go ahead and get them answered for you. And Dave, I believe you're also pretty active on things like Twitter and the social things.
Mostly Twitter. I'm more than happy to answer or chat with anyone on Twitter. My handle is Dave A. Glick. Okay. So if anyone on the stream has follow-up questions and wants to pick my brain, go ahead and hit me up on there.
All right, so there we go. So I went ahead and put that in the chat. All right, I know we had a handful more questions. Let me see if we could dig through these again really quickly. Can you use the static framework for Blazor components? This question is coming in from YouTube.
Yeah, so that's an excellent question that I've gotten many times in the last year since Blazor has kind of taken off. Okay. Right now, no. I mean, not directly. You could conceivably rig up some stuff on your own. I mean, static framework is sort of like ASP.NET in the sense that it's a framework. So you can build extensions and kind of build out your own app with it. But there's no native support for Blazor anything at the moment. Okay. There is, though, if you're interested in sort of brainstorming, there is an issue in the static framework GitHub repo to that end. So at some point, who knows when, we'll take a look at that and how to kind of integrate the two.
And static is also open source, so it's nothing stopping everyone from jumping in and sending a pull request.
Standard disclaimer that pull requests are accepted.
Pull requests are always welcome. All right, I'm going to grab one more question before we take off. This is also coming in from YouTube. Would it be possible to render a PDF in the browser to fill out some information? So I'm guessing this is when we were talking about some of those templating things a while back. So you're saying, if I get some information from the user, right, can I don't know, like your name, and I want to put your name on a certificate, right? And I render that certificate to the browser. Is that something that I could do using some of these Razer templating engines?
Yeah, so there are some client-side libraries that can render PDFs. So the way, just sort of spitballing how this might work, particularly using Razer, the way I would kind of go about doing that is on the server, I would have my Razer template that represents the PDF I want to generate. And that would have Razer code that fills in the blanks with stuff from your model that you build up from your requests, just like you would for a web page. You feed that into one of the many open source HTML to PDF libraries and can then deliver a PDF to the client with the stuff filled in. and then there's a number of client-side PDF viewers out there. Mozilla makes a pretty good one called PDF.js.
Okay.
That's easily embeddable. But the piece where Razer comes into that picture in kind of this scenario would be gluing up the request model with your Razer templated code to produce the stuff that you can then feed to a PDF generator.
Got it. That makes sense. Quick question about your project, about static. James from YouTube is saying, I see $50 for non-commercial use.
Right. So the way Stack is licensed.
You talk about that really quick?
Yeah. Static Framework is completely open source and has a permissive license. Most of the code in Static, something like 95%, is inside Static Framework. So if a commercial use license is a barrier, Static Framework is there. It's usable. You can totally build whatever you want with it, and there's really there's nothing that's like reserved. All the good stuff goes in Static Framework. Static Web is a project that sits on top of Static Framework and has a license that has a fee for commercial use, but is free for non-commercial use. So this is kind of the open source licensing model. They call it value added, or there's a term that's on the tip of my tongue, I can't think of it. But the idea is you make the core thing, open core, that's the word I'm looking for. It's the open core licensing model. The core thing is completely free and permissive. Mm-hmm. Static Web uses Static Framework to create a set of kind of conventional pipelines. What that means is that Static Web lets you get up and running more quickly. If you want to write a blog, it's basically 5 minutes with Static Web. It's a little bit longer with Static Framework because you have to write up all the glue for that yourself. So that's the distinction. And so Static Web is what has a license fee for commercial use. But again, it's free for non-commercial use, and I want people to use it. So if you have any questions about that, go ahead and let me know. I'm a nice guy. I'm very open about how that works.
Got it. And last question, we're gonna grab this next one from YouTube. Sebastian is like, where did you find the beard?
that's a good attempt at his the accent there. Yeah. Where did I find it? I found it over the last year in bits and pieces. It just kept going. Yeah, I don't know what happened.
And going.
It's been that kind of year. Yeah.
Awesome. All right. Well, hey, Dave, this has been amazing, man. Thank you again for being a guest on the show one more time. And again, for folks that are interested in learning more about static, we did drop a link in the chat for Dave's previous episode that was almost exactly a year ago, last year, August. We talked about generating static web apps with static. So if you definitely want to go head over to our .NET YouTube channel and check it out. But that being said, I think that's going to be it for today. Thank you all so much for joining us. Definitely appreciate all the folks that have been here from all over the place, all the countries I didn't get to shout out, like Algeria. I saw we have some folks here from Barbados. Awesome. Yeah, we have some folks here from Barbados. We have some folks from all over the place. So definitely appreciate y'all being here. Thank you so much. And I hope you join us again next week. We'll be back. All right. Bye, everybody.